Assalamualaikum and hi everyone. I'm gonna explain about chapter 3 past year paper. So we start with 2011 and 2012. For the first question for 2B, a potential difference of 15 volt is applied across a uniform wire of length 2.8 meter and radius 0.3 centimeter. If 0.6 ampere current flows in the wire, calculate the resistance of the wire. So the first question is asking for the resistance of the wire. So you use the Ohm's law, V equals to IR, where V equals to 15 volt and R we want to find. So the R is equals to 25 ohms. Second question is asking about the resistivity of the wire. So the formula of the resistivity of the wire is rho equals to RA over length. So we need to find the area of the wire first using pi r square. So the radius is 0.3. Change to meter, -2 square. So equals to 2.83 exponent -5 meter square. Insert the area into the equation here. Okay, so we get the value of rho equals to 2.52 exponent -4 ohms meter. Second question is from the 2020 and 2021. Okay, figure 2 shows R1 equals to 10 ohm, R2 equals to 12 ohm, meanwhile R3 is 5 ohm. Calculate the effective resistance. So the first step we need to solve is, we look at the diagram here. R2 and R3 are connected in parallel. So solve for the first R2 and R3. So R23 is parallel, meaning that 1 over R2 plus 1 over R3. So 1 over 12 plus 1 over 5. So R23 equals to 3.53 ohms. Okay, next, after dissolve the R2 and R3, we left with a new circuit here. Okay, so we have R1 here and R23 here. R1 and R23 are connected in series, meaning that R effective equals to R1 plus R23 plus R23 equals to R1 equals to 10. So 13.53 ohms for the first question. For the second question, we have to find the potential difference across R3. Okay, so the tips for doing this kind of question, first of all, we'll make a small table, series and parallel. For current, it will be equal. For parallel, it's gonna be sum up. Vice versa, for voltage, gonna be sum up. For parallel, it's gonna be equal. Okay, so for the second question, you want to find the voltage across R3. Voltage across R3. In order to find the voltage across R3, we need to find the value of current across I3 first. So the first step, we do the equation. I total equals to I1 here. I1 parallel equals to I2 plus I3. Why I2 plus I3? Because this circuit are connected in parallel. This one, parallel. Okay, the next step, we do the voltage. Voltage total equals to V1 plus V23, because R1 and R23 are connected in series. This one. Okay, so for V23 are connected in parallel, meaning that V23 equals to V2 equals to voltage across 3 also. So in order to us to find the value here, we need to find the V23. Okay, so for V23 is from this one, this equation. V total equals to V1 plus V23. V total is 15 volt. V1, we need to find the V1 first. So V1 equals to I1 R1. R1 are given is 10 ohm. So we need to find the I1 first. To find the I1 is equals to I total, meaning that we need to find the I total. So V total equals to I total R effective. V total is 15 volt. I total we need to find R effective from this one, 13.53. So I total gonna be 1.11 ampere. After finding out the I total, you can find the value of V1. This one. So V1 equals to I total or I1 1 over 1.11. R1 is 10 ohm. So V1 equals to 11.09 volt. After finding the V1, you can find the V23. Okay, so V total is 15 volt. V1 is 11.09 plus V23. So V23 equals to 3.91 volt, meaning that V23 equals to V2 equals to V3. Pressure difference across resistor 3 is equals to 3.91 volt. Okay, the third question is from 2019-2020 3B. So we have one series circuit here, consists of 2 resistors. The first question, calculate the output voltage. Okay, so the first step, the formula for V output over V total equals to, we label this one first, R1, R2. So output across R2 over R1 plus R2. Why R1 plus R2? Because this circuit connected in series. Insert the values here. V output equals to R2 is 3000 ohm, R1 is 6000 ohm plus 3000 ohm. V total equals to 12 volt. So V output equals to 4 volt. Okay, next question. If a voltmeter of resistance 3000 ohm is connected across the output. So we have another resistance here. So let's name as the R3. Determine the new reading of voltmeter. So the second question, we solve this one first. Okay, R2 and R3 are connected in parallel, meaning that 1 over R23 equals to 1 over R2 plus 1 over R3. So R2 is 3000 ohm. R3 is 3000 ohm. So R23 is equal 1500 ohm. The same procedure as we did the number 1. So V output over V total equals to the new R23 over R1 plus R23, because we have R1 and R23. Insert the values here. 1500 over 1500 plus 6000. The total is 12 volt. Final answer gonna be 2.4 volt. Okay, that's all for this number. Thank you guys.